Hello and welcome to the ENVI tutorial series part 1. What is ENVI? My name is Christopher. This series is planned to be a part of a course. It's tutorials on ENVI version 4. And in the end of this series you will be able to model an urban environment and analyze this environment in terms of solar radiation, wind conditions and other conditions in the urban environment. In this part I will briefly tell you what ENVI is, what kind of tool it is and how it is downloaded. Okay, open a browser and type in ENVI. I already did this before, and you can see here the top response in Google shows you this page. This is not the ENVI tool itself. It's pointing towards a consultant company, and this company is run by the main developers of ENVI. I'm not associated or part of any developments of ENVI or this company. But you can see this icon. If you press this, you will go to the start of download page and the information around ENVI. Alright, we'll start at this page and we'll come back to that a little later. First of all, we go to downloads, the ENVI version 4. This is what we are using. This tool is free to download. You can use it in any ways you want, as long as you don't earn any money on it. So in our case, in this academic forum, this is completely fine. So you download the trial or this preview version. This is what we have installed on our computers at the moment, and if you want it on your personal computer, you download and install that. Now I'll just briefly go over what ENVI is, just based on this web page. By pressing on this Hitchhiker's Guide to ENVI, you will see this page. You can press this picture, and you can actually this is like a visual representation what ENVI attempts. It is a multi-model that can simulate radiation and wind conditions and other conditions like soil responses to humidity and solar radiation hinted in it. If you press this, you will go into like an overview of the ENVI system, and you can just briefly see here what the different modules, the calculations modules, are able to do. The atmospheric module is typically the wind and radiation calculations. There's a temperature and humidity model in here, a turbulence model, which is typically used in most CFD softwares. Then there is the model is able to show the fluxes of different surface radiations and so on. And then there is a dispersion of pollutants model that can model, for example, ozone and NOx and these things. And down here you can see the different other models. We will not go through these in the series, but I urge you to read just the overview to get a brief idea what this simulation tool can do. In our series, our interest is the built environment and building systems. However, in this basic series we will not go into the actual building physics inside the building, but only see and watch what's happened on the outside. You will find that there is methods in this tool to actually couple indoor environments and like building energy modules and the urban environment. And you can actually see by pressing more here that you are able to calculate different types of materials in buildings, and you can see the heat actually running through the building and out of the facades like this. Again, this is not part of our series, and I will just show you this so you understand that this tool is actually able to do a lot more things than we are using it for. This site is kind of important if you want to read more of what ENVIMET is about, and it's built in a way that you can save these pages of read more. If I, for example, press this, I can go in and read about the model and the soil systems and these things. This is typical building models or the simulation models, and then I can add this to my book. When you log in, your book is clean, but I have like already saved different information pages in my book, and just press it here, and you can actually see all these things I've saved. And what's kind of important for you to read is the typical applications, what ENVIMET is, and this is what we'll go over this in this lecture series. And then you will see that there is other type of applications you can use. As an example, you are able to actually use Google Earth to download a picture to place underneath the site you are working on. The best way to explain how ENVIMET works is actually to go to their Facebook page. It's kind of interesting, but you will see here there's a small picture that actually visualizes how ENVIMET works. ENVIMET itself is a simulation engine. It utilizes different types of input. These inputs may or may not be created in an ENVIMET tool, but not the tool itself, and I will show you that later. It also produces different types of output files, which ENVIMET itself are not able to visualize. Then you will actually have to use another tool to visualize this. But this is fortunately also part of the ENVIMET package. This means that ENVIMET, when you download it, is actually a different types of softwares that is called ENVIMET, or reference to ENVIMET in total. But ENVIMET as a tool is actually this thing that is simulating the different environmental conditions. Now I'll show you what ENVIMET is. I've already downloaded and installed ENVIMET, and I will find it in my ENVIMET 4 folder. It's based on my hard disk, and it's advised that you install it on that in this place. You will find different exe files, and exe files are typically these self-running files that is considered as a program. And as I told you before, ENVIMET itself is actually part of a larger environment. I will just start by introducing the headquarters. So I'll double click this. Here we'll see like an overview of the ENVIMET tools that you have in your folder here. There's this biomet we're not going into. There's this eagle eye that I told you before, which utilizes Google, the Google Maps. And then we have the config wizards, we have spaces, and ENVIMET itself, which can run in different variations. We have to define a space where our ENVIMET folders and ENVIMET files will be situated. The way you can do this is to go to Manage Projects and Workspaces. I'll do it here. You will see on your machine that there is no projects in this window, but you're able to select projects, or you can create a new project. We will start to create by creating a new project. I can call this tutorial series. And I can give it a description. I'll just call it tutorial. The project folder could be the same as I have already defined. I will make a new one, so we'll just call it tutorial project. You shouldn't press this because then you don't have any database in it. So let's just apply. Yes, I do want to do that. You will probably see some German language popping up once in a while, but it makes sense. Ja means yes, I guess. So in the headquarter you will find the different tools that brings ENVIMET together. You will find the same tools inside the ENVIMET folder. There is no specific way you can use this tool. I am using it in a particular way that I found useful, but you may find it useful to use this headquarter more than I am. So I will just stop the headquarter and go directly to the subtools that is being ENVIMET. ENVIMET itself is actually 3 different versions, and these 3 different versions are this 40 by 100 by 100, 40 by 180 by 180, and 40 by 250 by 250. These numbers is referring to the amount of cells that the simulation tool is using when it's calculating the environmental impacts. You have to be aware that taking the decision of making a really big file would hugely impact the amount of simulation time. So I will only say this briefly, but I will usually go with the smaller the smaller file for test purposes, and for documentations I will go for the more precise models. At this point we will normally start making the geometry used for the simulation. However, to explain how the ENVIMET tool works, I briefly want to go over the project wizard first, which is normally used after we create a space. In the project wizard you will see what conditions a simulation will take, and this will give you an idea of what ENVIMET is. So first of all, we open the project wizard. This is our project wizard. You will find your tutorial series, if you called it that, in this drop down menu. I have currently 2 different projects, but I will use tutorial series to start with. Before we ran the project manager to create this space where our files will be situated. So we don't need to run the project manager now. You can either open an existing simulation, we don't have any now, or make a new one. This next button doesn't do anything. We'll now create a new project configuration file. To begin with, we haven't got any 3D area input file. We haven't got any model to actually simulate upon. However, to go through these setups to actually understand what we are trying to do, I will just select a file. This one, in our case, Central Park. And you can see a preview of the file here. It's this gray ones is supposedly, I think it's buildings, and the red ones are I think it's foliage, something like that. Doesn't matter. We'll go to the names and folders. You can either press next on names and folders here. We'll call your project something and a name for your configuration file, and you will set it up in one output. For this project here, I'll just select a project 01, but it could be your tutorial project. So now we are simulating at the summer solstice, which is the longest day in the year, and we will start our simulation in 7 AM. We will simulate for 24 hours. This means that will have 24 outputs, because the ENVI will export each hour as an output file. And here you can, from each hour, you will find all kinds of different environmental impacts. If you want to use the hours from 7 AM, you might need to change the simulation time to 5 AM, since the 2 first hours can be unreliable. We don't want to change any of the output settings here. One more thing, you can, of course, this is for a summer situation, you can do the exactly same with the winter situation, which could be the this winter solstice, for example, the shortest day of the year, and do the exact simulation for same simulation. For our purpose, we will just look at the comfort in the summer situation. You could make it more nuanced, of course. In this section, we will define our wind direction and our wind speed. Wind speed at 3 meters per second is low wind breeze, and 12 meters per second or above that is considered harsh or stormy weather wind conditions. The direction is set to 90. This means that in our model, up is 0, and clockwise 90 is from the right, and 180 is from the bottom, and so on. If you want to have the wind from the east, for example, we just press 270. We'll just set it as a western wind. You have to bear in mind that this is according to your model and not the true north. Here we will input the roughness of the measurement site. The idea is that we have a partial space of our site cut out of, for example, this area input file, which is like some kind of park here and then some buildings. Of course, we will have other buildings around, and what this number represents is the roughness of these exterior conditions. And in general terms, you can say that a very smooth roughness, a low number, is a area which has less buildings, like an open plain, or if you are situated on water, or where you don't have any obstructions. And 0.01 is considered an urban environment, and 0.1 is a very rough environment, or very it could be like in New York downtown, where you have high buildings and these conditions here. Here you can set your temperature of your model. This is the initial temperature, but the temperature will be recalculated from this according to the solar radiation and your site. You have to change this according to which kind of simulation you want to do. Now we are making a summer simulation, which means that we can assume a slightly higher temperature. In a winter situation, we might go down to, let's say, 2 degrees or something like that. Please look into your weather data before you make these decisions. You also need to change the conditions of the humidity, and the relative humidity and the temperature is coupled. There is another way to control temperature, which is by forcing the temperature. You can do that by pressing this button, and then you can use these toggles to create a profile like this, where your temperature will be forced to be in a certain level, and the relative humidity will be coupled to that profile. We will just go with the basic settings. In these next steps here, we will not edit any of these basic settings, but I will just go through them. In the solar radiation, we can adjust the amount of solar radiation at the site, assuming, for example, that we have a really polluted area where our radiation cannot get up to the measured ones in other situations. We can modify this as a lower fraction, and also we can adjust the clouds. This is another way to do it. We can change the CFD model controls, like the turbulence model, and the boundary conditions here. I don't want to go into the details about that. Next, this is the simulation during runtime, where we can adjust the time and time steps. Again, I don't want to change any of these, and I will let these wait as default values. If you really are into the site in terms of soil and plants, it might be a good idea to change the temperature of these depths. Of course, you need to know what you're doing before you do that. Also, there is a opportunity to put in another plant model. By default, there is only one plant model, so we choose that. We can change, however, the background level of our ppm in CO2, which may represent. You may change this according to a site where you have which is situated to a forest or something like that. Pollutant and dispersion. In this section here, you can actually simulate other pollutants, and we are limited to just simulate single pollutants at a time, and no chemistry allowed here where the pollutant is actually interacting. What you can do, you can choose upon these between these. It could be, now CO2 is in the model, but you could simulate carbon monoxide, or you can you could simulate nitrogen or something like that if you are interested. We are not using any pollutants other than CO2. And then there's the expert settings, which is scripting. So we'll do that. Finally, we save the model, the configuration model here, set up in a place which is of course in our project folder. And after we done this, we can start simulating. And this will be the end of part 1. And if you have questions, you can just post them. Thank you.